Hello and welcome to yet another lecture on power generation and economics. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. So previous class we have seen that different types of factors are generally related with the economical power generation. Now today we will see those applications, how those different types of factors are related with the economical power generation. So let us start with a numerical problem. It is given that an industrial consumers has a daily load pattern of 2000 kilowatt 0.8 power factor for 12 hours and 100 kilowatt unit power factor for 12 hours. So calculate the load factor. So now we are approaching towards that particular problem. So load factor is generally known to us. Load factor equal to average load by maximum load. Average load by maximum load. This is the relation of the load factor. Average load by maximum load. So it is given that if we multiply upper and lower limit, means the numerator and the denominator with the time t, we can multiply in order to find the load factor. Okay, so now it is given that this 2000 kilowatt, it is 2000 kilowatt having a power factor of 0.8, having a power factor of 0.8 and time taken 0.8 and the time taken is the 12 hours. This one plus 1000 kilowatt having unity power factor and time taken 12 hours. This is the total average load divided by the maximum load. So what is the maximum load? Maximum load is 2000 having a unity power factor and is run for the 24 hours duration. Total day 12 plus 12 24 having a highest power factor 1 and the highest load is between 2000 and 1000 is 2000. So after calculating we are finding a load factor of 0.6. This is our answer. This is the answer of that mathematical problem. It is given that a industrial consumer has a daily load pattern of 2000 kilowatt having a 0.8 power factor. It is run for 12 hours. It is given that it has a 2000 kilowatt 0.8 power factor run for 12 hours plus 1000 kilowatt having unity power factor run for 12 hours. This is our average load calculation. Now for the maximum load calculation between 2000 and 1000, 2000 is the maximum. Between 0.8 and 1 is the maximum power factor and total hour is 12 plus 12 is the 25 because we are multiplying with the T upper and we are multiplying with the T factor for the numerator and the denominator. So the total, this is the maximum power demand and our output is 0.6. This is the answer for the load factor for the first mathematical problem. Now we are approaching to the second mathematical problem. It is given a power station supplies the peak load of the peak load values 50 megawatt, 40 megawatt and 70 megawatt to three localities. The annual load factor is 0.50 per unit and the diversity factor of the load at the station is 1.55. Find the maximum demand on the station and average load. Find the maximum demand of the station and also the average load. We have to find the two things. Okay, now you go for the solution. Now, it is given that the diversity factor is 1.55. Diversity factor is nothing but the sum of all the individual peak loads. So it is given 50. The peak loads of a power station is 50 plus sum of the individual loads 40 plus 70 megawatt. So the total sum of the individual loads divided by we have to find the maximum demand of the station. Our first problem is to find the maximum demand of the station. Maximum demand of the station. So this is the relation of the diversity factor. It is given 1.55. It is the sum of the individual loads, peak loads, 50 plus 40 plus 70 divided by the maximum demand. So from there we can easily find the maximum demand of the station. So what is maximum demand? So the maximum demand is found. Sum is 160 divided by 1.55 equals to 103.22 megawatt. This is the maximum demand of the station. This is the maximum demand of the station that we have found. The first part, that is to find the maximum demand of the station, and the second part is to find the average load of the station. So this is the maximum demand part. Now we have to find the average load of that particular station. So we will find the average load of the particular station. So we know that the average load from the equation of the load factor is the ratio of average load to the maximum demand. So average load is the load factor into maximum demand. Maximum demand. So maximum demand we have just found 103.22 megawatt. So the average load factor is given here clearly 0.50 pu. So just write 0.5. It is multiplied by the maximum demand that we are getting 103.22. So the value is 51.61 megawatt. This is our average load. This is our average load. So the maximum demand and the average load is found by that particular solution. The solution is found on that particular problem. Now going to our third problem. Third problem is that a generating station has a maximum demand of 50 megawatt, a load factor of 60%, and a plant capacity factor of 45%. And if the plant while running as per schedule were the fully loaded, find the running energy produced. The running energy produced or the daily energy produced by the plant. We have to find it. Okay. So let's do that particular problem. So again we went for the load factor is the average demand by the maximum demand. Average demand by the maximum demand is known as load factor. Average demand load factor. So it is given that the load factor is 60% and the maximum demand is 50 megawatt. So load factor is 0.6. We have to find the average demand and maximum demand is 50. So what is our average demand? The average demand is 0.6 into 50, that is 30 megawatt is our average demand. The average demand that we have done. So we have to find the daily energy produced by the plant, or what is given in the question, running energy produced. It is mean the daily energy produced by the plant. So just go through the load factor and the average demand part. The average demand is 30 megawatt. So daily or running means it is run throughout the day. Daily or running energy produced. Daily or running energy produced. Average means per hour. It is per hour, it is generating 30 megawatt. So for 24 hours, it is generating. For 24 hours, it is generating 720 megawatt of energy. This is the running or the daily energy produced by the plant. It is the running or the daily energy produced by the plant. Now let us take another problem. A generating station has a maximum demand of 25 megawatt, load factor of 60% and a plant capacity factor of 45%. And the plant use factor of 72%. What is the reserve capacity of the plant? If the plant while running as per schedule were fully loaded, we have to find the reserve capacity of the plant. Okay. So in order to find the reserve capacity of the plant, we are now approaching. What is the load factor again? I am going for the load factor. I think this is the average demand. I am writing that as the average. This is average by maximum demand. Average by maximum demand. This is average by maximum demand. So it is given that the load factor is given. So what is this? The load factor is given in the 60%, means 0.6, and the maximum demand is 25. So what is the average demand? So we can find the average demand. We can find the average demand, that is the load factor, means the load factor is 0.6 into maximum demand is 25. So the total is 15 megawatt. Total is 15 megawatt is the 15 megawatt is the average demand. So you have to find the reserve capacity of the plant. So this is the average demand of the plant. Okay. So now, what is the plant capacity factor? What is plant capacity factor? So what is the value of plant capacity factor? Plant capacity factor is known as average demand, average demand by installed capacity. Average demand by installed average demand by installed capacity of the plant. So what is installed capacity? Installed capacity is the average demand by plant capacity factor, and it is given that the plant capacity factor is given as 50%. The plant capacity factor is given here. The average demand that we have found is the 15. The average demand that we have found is the 15. The average demand that we have found by the 15. So plant capacity factor is given as 45%. So the installed capacity that we have found, is the average demand, that is 15 by plant capacity factor 0.45 is 30, is given as 33.33 megawatt. 3.33 megawatt. Okay, so we have found the plant capacity factor 33.33 megawatt. So now it is given the reserve capacity. So it is given as reserve capacity of the plant. We have to find the reserve capacity of the plant. We have to find the reserve capacity of the plant. In order to find the reserve capacity of the plant, is the plant installed capacity 33.33 minus the plant maximum demand, that is 25. So it is found as 8.33 megawatt. This is the reserve capacity of the plant. This is our answer. This is the reserve capacity of the plant. Now, the problem that we have given that the load duration curve for a power station is shown in the figure below. Find the reserve capacity in the plant at 70% capacity factor. This is our graph. Okay. So we have to find the reserve capacity of the graph from that particular. We have to find the reserve capacity factor of the plant, reserve capacity of the plant from that particular graph. So let's do it. Let's take our problem. Just go to the problem. Search for the problem. This is 50. This is 90. This is 0. This is 100. Here this is the time. Axis. And here it is the generation of the power. Okay. So we have to find the total area under the curve. This area is the area of the triangle and this area of the rectangle. So what is the area of the triangle? The area means if we write down as a B, C, D and E. So the total area under the curve, the graph is the area of the triangle, sum of the area of the triangle EDC, sum of the area of the triangle EDC plus area of the rectangle AB, CD. So what is the area of the EDC? Half into base. Base means 0 to 100, this part. Base means DC. DC. Can I write in that way half DC into DE, the height, and area of the rectangle ABCD is length into breadth, breadth into length, AB into AD, or DC into CBC. Okay. So let's take what is the DC value. DC is nothing but from that equation you can find DC is nothing but AE minus AD. Okay, so AE is the 90 value and AD is the 50, so DC is taken as 40. Okay, so DC is taken as it's a DC value. No, it is the DE value. I think we must go for the DE value. Sorry, DE is taken as 40. Okay, so DE is this part. So DE is this part. Okay, the value of that particular part. Now let us take what is DC? DC is the this part. This is 100. So into DC is the 40. D is the half. DC is given as 100. D is given as 40 plus AB is given as 100 and AD is given as 50. So if I take 100 common, so it will be 20 plus 50 into 100. You can write this 70. 100 is the total time, so 70t. You can write that. Okay. The portion is known to us. So we can calculate the area. Now we have to find the capacity factor of the plant. Capacity factor or plant factor. Plant factor is given as total energy, that is consumed 70t, right? Maximum plant rating, right? Plant rating, plant rating, T. So what is the plant rating? So plant rating can be specified. Plant rating can be defined as between P by plant capacity factor, which is given as 70%. This one, 70%. 7, this is a 100 megawatt. This is the plant rating, 100 megawatt. So what we have to find the reserve capacity of the plant. So reserve capacity of the plant can be found as plant capacity minus peak load. So plant capacity we have just done is 100. And what is the peak load? Peak load is fine from here, 90. 90 is the peak load. Peak load is 90. So peak load is 90. Is the 100. Is the 10. So the answer is 10 megawatt is the plant reserve capacity. This is our answer. So we have done the how we can approach using different values of the different factors in order to obtain the economic power generation. How different factors come into play in order to generate the economic power. Thank you.